Okay, class. This is our sixth online lesson and our fifth in the series of dynamics. We're continuing with the same component of forces. Okay, let us take this example from exercise 5C. A force of 30 Newton acts horizontally on a particle of mass 5 kg. Okay, and there is a smooth rest on a smooth slope. It's very important to note it is smooth. Okay, find the acceleration. Our job is to find the acceleration with which the particle will move. Now first of all, there will be hidden forces. There will be forces which you have to draw basically. So now see, because there is an object, it will always have a weight which will always act vertically downwards. A reaction force will always be perpendicular to the surface. Okay, that's why the reaction force is like this, and this force need to be resolved now. So that's why I just went, you see, you just go parallel to the r, that will give you the vertical component, and parallel to the surface, that will give you the horizontal component. Same weight again. In the previous example I told you in the earlier video that we take the plane as the x-axis, so r becomes the y-axis. So this weight mg is neither horizontal nor vertical, so we need to resolve this also. Again the same idea, just go parallel to r, that will become your vertical component, this is your horizontal component. Now they only gave you that this angle is 30. The other angles you can use your mathematics to find. See, if this is 30, we know this is 90 degree here where I'm pointing now. So this angle here where you see my pointer is 60 degree. Okay, and again this angle is 90. So if this is 60, this will be 30. So this will always be equal to this basically. This is how I got this as 30. Also because this is horizontal force and this is also horizontal, you will see they are parallel and they're making alternate angle. You see this Z alternate angle, so this angle will be equal to this angle. That's why how I know that this will also be 30. Now this is opposite, that's why this is the 30 Newton force, so 30 is the force, sine 30 is the angle. Again 30 is the force, cos 30 because it is adjacent. Here the force is mg, this is 30, so this is opposite now. So this is mg sine 30, this is adjacent mg cos 30. Now let us solve. Very important to note, this is smooth, so there is no frictional force. That's why you will not see I did not draw any friction force here, because it is smooth, we can ignore the friction. Now see, also note here, I did not make a horizontal arrow or a vertical arrow because I'm saying that this is my x-axis or this is my horizontal. So horizontally the object is in motion. You see, again F equals to ma, resultant force is mass into acceleration. If you look at this direction, there is a force here which is in the same direction, and there is a force, horizontal force here, which is in the opposite direction. So this will become minus, this is plus, so that's why 30 cos minus this equals to mass into acceleration. We know mass is given to us as 5. If I just rearrange, solve, I got the acceleration, and that's it. Next, again I want you to pause your video here, try to solve this question on your own. Okay, let us start. First of all, draw the forces which are missing. Okay, so if I first draw the forces, it will look something like this. If you see in the red color, first of all there will be a weight acting downwards. Weight is always vertically down, normal reaction is always perpendicular to the surface. And now this time they did not say it is smooth, it is a rough surface. You see here the pointer, rough, so definitely there will be a friction. Now see, the thing is, this 6 Newton force might be enough to push it up, to pull it up, whatever, or maybe it will still drag down. So when you don't know in exam, yani let us say you don't know whether this will make it move up or will make it move down, it doesn't matter at all. If I am assuming this side, okay, the object is going up, so friction will be acting downwards. If my assumption is wrong, all that will happen is I'll get a negative answer. It's vector. So and hence I will know that the object is moving down and friction will be upwards. And if I get a positive answer, yani this assumption is correct. Okay, so you don't have to worry about that. And secondly, the question says, where is it? Given that the particle is moving with constant velocity. See, this is a very important point. Don't miss this. Constant velocity means acceleration is 0. So in other words, the object is not yani it's in equilibrium. Let us take that. I made a note here. See, or acceleration is constant velocity, acceleration is 0. So the same F equals to ma, the resultant force equal to mass into 0 is 0. and when you solve this you get negative 15, and as I told you, negative implies the particle is moving down the slope and the friction is in the opposite direction. So we say the frictional force, the question says what is the frictional force, it is 15 Newton up the slope, and that's it. Got it? Let's go ahead. I want you to solve this question. This is question number 8. Try to solve this question on your own, and that's it.